Hi, this is Rick for EDU Mobile. We're going to start talking about the Swift programming language. If you got the course early, or if you have the course now, you have a Swift primer, and you should probably go through that. But in the actual course materials, the discussions, the demos, and so forth, we're going to take a much more detailed look at the Swift programming language and how we use it. So if you want to go ahead and look at the primer to get an overview, that's fine. But now we're going to start actually talking about the language in detail. The first thing we talk about in any language, aside from Hello World, is the variables and constant declarations in that language. Constants are very important in Swift, and we'll talk about that here in just a moment. So how do we declare these things? We declare a variable using a keyword var. Here we have a variable declared with a name amount and set equal to 32.5. This is inferred to be of type double. Amount doesn't have an explicit type set for it, but in Swift we have type inference. So the declaration sees 32.50 and says, it's a double. Why not a float? We'll talk about that here in a minute as well. Numerals are inferred by their value to be either of type int or type double. We can declare a constant using let. So red here is of type int. It's inferred to be type int. And we have a hexadecimal integer. By the way, colors are alpha RGB in 1 byte hexadecimal values if we see them like this. So this is an FF alpha and an FF0000, red, green, blue. So we've already seen types are inferred by Swift according to the value in the assignment. Amount is inferred above to be double, and red is an int, by the way. Double and int and other what we would think of as primitive types are actually classes in Swift, so they are capitalized. So red and amount are both objects, not primitive types in the sense that we think of them. They are allocated on the stack, but they're objects in every sense. So why do we have variables and constants? Of course we have constants in other languages, we have constants in C and so forth. The idea here is to use var only for values that will change and to use let for everything else. So variables should only be things that will have changing value in our application, whereas everything else should be declared as a constant. And this way, we have a little bit more safety imposed by Swift. So what about these value types? Value types are allocated on the stack even though they are objects, and they are passed by value. In Swift, there are 5 primary value types, and they are int, double, string, character, not char, character, and bool. So character is spelled out. All untyped declarations will be inferred to be one of these 5 types. So that's why if we have a value of 4.8, it is a double type. If we have a value of 9, it is an int. We can also annotate a var or a let declaration with a particular type. So how does that look? Well, the primary type for an integer is int. However, we have subtypes. We have int 8, which is an 8-bit integer, a 16-bit integer, and we have unsigned values for this. So we also have a uint32, a 32-bit unsigned integer, and so forth. All type names in Swift are capitalized. Once again, the types are class types. So int 8 is a class, and if we declare a value of this type, a var of this type, or a constant with let, this is a class. So to annotate a var or a let declaration, we use a colon followed by the type. So here, days of week assigned to 7 is an unsigned 8-bit integer, whereas my number is a signed 32-bit integer. Now, we probably wouldn't use assigned 32-bit integer to store negative 274. A signed 16-bit integer would be fine, but a signed 8-bit integer would not, because all we have is negative 128. So double types. The double primary value type has only one subtype, float. So we can have a double or we can have a float. Double is a 64-bit value, float is 32 bits. So if we want a float, we need to tell it that it needs to be a float. We need to annotate with a float annotation. So here temperature is 27.1 degrees, and whatever scale we're using, temperature is annotated to be of type float. If we leave this out, it's a double. So what about string, and what about character? String is a value type in Swift. It is like a primitive. It is allocated on a stack, but it is a class. So strings are objects of type string, but it is a value type, unlike NSString and Objective-C, which is a reference type. Basically, the idea in Swift is that anything that is int, double, float, character, or bool is going to be a value type. And their values are passed around, not references to their values. Anything else, anything that whose underlying type is an actual declared class, any object type, is going to be allocated on heap. But there's a distinction between these 5 types and everything else. So here's the idea also is that string in Swift is bridged seamlessly with Objective-C's NSString class. So we can transpose strings and NSStrings interchangeably. So here's an example. Language equals Swift is inferred to be a string. However, if we want to have a character, we can have a string containing only one character. This is inferred to be a character type. Of course, we can use these types in annotations. So greeting as a string, hello, we can do that as well. If we need a one-character string as a string type, we would need to annotate it as a string. Okay, bool is true or false, not the Objective-C yes or no, not some other weird 1 or 0. The values are true and false only. So no semicolons in Swift, by the way. We've seen that already. But we have a variable declared here, is odd, and it is said to be a bool. Now notice that we are not assigning this. We'll talk about this later when we get to optionals. But here we're again saying is odd is a Boolean. We don't know. We don't know which way. We don't know whether it's true or false at this point. It is just a Boolean variable. Then we have let num equal to 9. So this is a constant 9 called num. So if num mod 2 is equal to 0, this evaluates to a Boolean condition. Num mod 2 is equal to 0 will either be true or false. So if this is, if num mod 2 is equal to 0, then our number is not odd. So is odd equal false, else is odd equal true. So pretty much what we would expect in terms of syntax. There are no semicolons, and there are no parens in the condition for this if statement. Conditions don't have parentheses in Swift, and we don't have to use semicolons, although we can in Swift. The condition of an if statement or the condition of a loop, however, must evaluate to a bool. In C, we have things like if is odd. In Objective-C, we have that as well, if is odd. We can't do that here if is odd is unassigned. We can't just say if is odd, and if it comes back as nil, let's say, some non-value, then it's false. That is not true in Swift. Is odd needs to have a value before we use it. Okay. Also, the conditional of an if statement, the conditional of a while loop or do or for loop must evaluate to a Boolean, a true or a false value. All right, so initialization, we're going to kind of wrap this up now before we have a demo. Variables and constants should be initialized before they are used. Constants are initialized before they're used. We can't just say let age and then not assign it. But a var declaration, we can. We can say var age colon int, and then not assign it. So with a variable declaration, sometimes this isn't possible to pre-initialize something. So for this case, Swift provides something called an optional syntax for cases where a var or value of some kind cannot be initialized before it's used. And we'll talk about how those optionals are used in discussion 2. Thank you very much. I hope you enjoyed this chapter as much as I enjoyed making it. I'd like for you to take a couple of minutes of your time to please leave some honest feedback or a review, and then message me for your surprise bonus. I'll see you in the next chapter.